Hi, so this video is all about letting the Raspberry Pi communicate with the cloud database, specifically the Firebase Firestore, so that we can control our GPIOs. So let's get started. First off, I used Visual Studio Code wherein I set my Raspberry Pi uh, in remote development setup. So basically using SSH I can code remotely. So I use Visual Studio Code to to code. So first off, let me just update my Raspberry Pi. There's an update. So if you have a Raspberry Pi, make sure you make this an habit so that to keep your Raspberry Pi updated. So there, done. So um, first, let me make a Python script. So let's just call that Raspberry Pi Firestore.py. So everything is really easy here in Visual Studio Code. You can, unlike when you code directly in the Raspberry Pi, Raspbian OS, the Thony IDE and the Genie, it, I really much prefer Firestore. I mean the Visual Studio Code. So without further ado, let's go on to the firebase.google.com website to set up our Firebase project. So if you are here on the website, go to console. So my internet is kind of slow right now. So let's wait. Now, if you're new in Firebase, you probably have no projects at all yet. So just click Add Project. So that's what we'll do. We have a slow internet right now. Sorry. Click Add Project. So enter a name. I would just like to call this project uh, Raspberry Pi RPi Firestore. So can only so no underscore RPi Firestore. Click continue. Then I would like to disable this Google Analytics because purely this video is just a tutorial. So great project. So this might take a while to set up your Firebase project. So just keep waiting. Now click continue, then you'll be directed to the Firebase console. So this is the home page. So the first thing that you need to do is enable Firestore database. So as you can see, Firebase offers two databases actually. So one is the Realtime database, and of course the other one is the Firestore database. So the reason why I chose Firestore database, I mean both of them are actually quite the same. They're both offer a real-time syncing, um, and also they're also in a NoSQL database structure. So personally, I like Firestore database because this is actually is the newer one, the new database. The new database, and it has it is much more advanced and powerful in terms of like using queries and automatic scaling. So right now I'm working on a project wherein I develop a mobile app and I communicate it with a Raspberry Pi. So the Raspberry Pi is connected to the Firestore database and as well as my mobile app. So my app is actually focused on like data. So like searching data. So Firestore was definitely ideal in my case. So if you're like me, who is like querying is a concern, so definitely Cloud Firestore is a choice for you. So real-time database is also okay, and it offers real-time syncing, so which is also good. But the way it's structured is like in a JSON-like structure, and what that's what it makes really not ideal for querying. And maybe if you have a mobile app, you wanna choose Firestore database. So that is of course is my opinion. And so yeah, and it is also the newest one, and it also has like a server in my region. So uh I am in the Southeast Asian region. So again, sorry, I'm off tracking right there. So create database. Then right now I just opt to use test mode because this is just for tutorial purposes. But whenever you want to release an app or a client device, you want to make sure to click the start in production mode for. But in this case, let's use test mode so that we can freely edit or modify the data. So click next and choose the nearest or maybe the region or location where you are located. So I'm in again in Southeast Asia. So you can see that I have two server options right here, which is good. So let me just click enable. So again, this might take a while depending on your internet speed. And there it is. So we have properly set up our Firestore, and as you can see, it's currently empty. There's no data at all in our database. So let's get started in our Raspberry Pi. So so uh, before that, before we can use the Raspberry Pi, I mean the Firestore um, database, we need to install some packages or some dependencies to our Raspberry Pi. So you want to make sure to install Firebase admin. So under your terminal or terminal line, just hit click enter pip3, then install Firebase your underscore admin. So you want to make sure to install this first so that we can use the Firestore database, communicate it with, and also use some functions related to Firebase. So click enter. So as you can see, I've already downloaded it. So in your case, make sure to download it first. The next thing is to again I've already made a Python file right here in my Raspberry Pi. The next thing is um, you want to download a service key account so that your Raspberry Pi as a client can communicate or can connect with our Firebase project. So head down to settings, project settings, then go on to service accounts. So again, this is essential so that our Raspberry Pi can communicate with our Firebase project. So again, the Raspberry Pi is uh, whenever in development is in Python environment. So click on Python, and you want to just copy this code snippet, then go back again to your IDE, just paste it. Then after this one is finally this step one. This is another step to generate new private key. So click generate key. So this private key will clicking this one will download a JSON file wherein it contains all credentials related to your Firebase project, so that our Raspberry Pi can communicate with this Firebase project. So you want to transfer this again, as you can see right here, the downloaded file. You want to transfer this file to the Raspberry Pi, but you need to rename it first. But in my case, I would do it like this. Again, this is a JSON file, and I open it with a notepad. So this is the contents of that JSON file service key account. I don't care if you wanna uh, use this key or troll me. This is just a tutorial. So click, just copy all its contents. Copy. So go back to our IDE, and you want to make sure that this Python script has its own directory, if I make sense. So this one, I had a directory or folder of YouTube, YT. You can name it whenever you want. So you want to make sure that the code that you are developing will have the same directory of our service key account. So make a new file in the same directory and name it service account key, sorry, .json. Make sure that is the correct spelling. Okay, click enter. So then you paste all the contents here that you just copied the generated key. So and then there, click save. Just and you want to make sure to remove this unnecessary path. And then there, you're all set up. You have you're just you likely just established a connection or communication to your Firebase project. So now let's explore the Firebase NoSQL Firebase Firestore database. And by the way, I forgot to include the Firestore library. So this is, of course, is our concern to use the Firestore. So I want to make sure to import that one, Firestore. There. So again, you are all set up. So let's control our GPIOs and explore the Firebase Firestore. So in this video, the I/O devices that I am that will be working on and control it using the Firestore database are the following ones. So as you can see, I've already set up the uh, LEDs, the button. These are actually connected to the Raspberry Pi. So um, I'll put in here the pins. So just for your information, uh, if you want to know the pin outs of your Raspberry Pi, just enter here pin out. So right here. So this is one of the handy uh, command line. So as you can see, let's let's begin on entering. I mean initializing our IOs. So first, I'll be using the GPIO 0 library. So from GPIO 0, and I'm using LED for output, buzzer for output, and button for input. So let's use LED. Let's import. Sorry, import LED, and also use button. Also use buzzer, and also I have two LEDs. One is for like digital LED, and also I want to use the PWM LED. I'll be using this to uh, control the brightness of our LED, which is extracted from our database. So later on, you'll understand what I mean. So let's declare some variables for it. So my LED is in GPIO 20 over here, LED 1 and LED 2, and which is PWM LED. Let's declare it as PWM LED. It's in GPIO 21. Then the buzzer is in GPIO 17. So lastly, the button, uh, 16. So now that we've declared our IO devices, the LED, the buzzer, and the button, um, so now let's explore the Firebase Firestore. So again, as you can see, it's our database is empty at the moment. So let me just split it here. So now again, it's currently empty. So if you want to learn about a database, the first thing that you need to understand is, of course, its CRUD operation. So what CRUD stands for is create, read, update, delete operation. So again, Firestore database is a NoSQL database. However, it's quite similar to an SQL database or relational database. It's just that the way it's structured, instead of like a table-like structure, doesn't that is not true in NoSQL database, which is varied actually. There is from like a tree-like structure and much more. So let's first explore the create. Let's create a database. And let's create a like collection or a document in our database. And before that, let's initialize a variable for our database. So again, let's the Raspberry Pi is treated as a client of our Firebase project or Firebase Firestore specifically. So let's um, let's just enter Firestore dot client there. So this is what we will always call whenever we um, use the database, something like that. So uh, let's create some again data for to our Firestore. So the way I structure this is that we'll create a separate collection. Yeah, a separate collection for output devices. So our LED and buzzer is an output device, and button for input device. So let's do that. So again, you can always manually put it. I add it here using the Firebase console, but let's do it programmatically. That makes sense. So again, as you can see, our database is currently empty. So let's add some, or let's create some data on it. So let's begin with the again. We will do this in a crude format, step by step. So let's first learn how to create data on our Firestore database. So the way I want to store it is that again we'll be controlling GPIO or IO devices. So as you can see, LED and buzzer are for our output devices, and button is a input device. So let's create let's separate a collection for it. So one collection is for input devices and another collection is for output devices. Then under output devices are LED and buzzer. So let's do that. So let's just use our database reference. Then again, let's create a collection. First, let's create a collection output devices. So you can name it whatever you want. So output devices. Then under collection, you want to create two documents because we have three actually, three output devices. One is a digital LED, one is the PWM LED, and one is buzzer. So let's create first for our digital LED. Create document, then digital LED. So under that document are data fields. So as you can see, this is how the Firestore NoSQL database structure its database. So the root is the collection, then under collection are document, then under a document are data fields. So let's create some data fields on it. So make sure you want to have a curly brace right here because it's in a map format, uh, storing the data field. So let's say our digital LED. So let's have a status data field. So let's equate it into a boolean data type. So let's name it false. So again, the way I want to demonstrate this uh, uh, like later on is that whenever the LED is read as false, so it will turn off the LED, and if it's true, it will turn on the LED. So so far makes sense. So let's make another document for our PWM LED. So it's again under output collection, output devices collection. Let's name it PWM LED. And again, PWM LED is you want to let's say in this tutorial we want to um, display the brightness depending on what is entered in our database. So let's put it brightness data field, and it's going let's put it an initial value of 0. So again 0 as like no light at all, to 1 as its max brightness. So this actually is uh, a float or double data type, but in the Firestore it will read as like an integer. So we have PWM LED. We also have for buzzer under output devices again. So let's enter buzzer. The reason why I added a buzzer device because is if you have a project like relies on that has an alarm system, and it will only alarm depending on what is being fetched on a cloud. So this is an example for you. So let's name it alarm, and let's just make it a false boolean data type. So let's try to enter this, run this one first, and we'll see if uh, our Firestore will update it. So as it says, it's a real-time syncing. So let's click run here. So maybe, yeah, let's not me reload this one because my internet right now is really slow. So there, as you can see, it creates this one. Create a output devices collection, a buzzer document, a digital LED document, and a PWM LED. So as you can see, each document has its own data field. So you can actually edit right here in this console panel. So again, Firestore offers a lot of data types. So now we're good in the output devices. Now a let's create one for our input devices. So let's create another collection. Let's name it input collection input devices, and this is for button. So name it button our document, and currently it's reading, and let's name it reading or just value. So if I yeah, false. So let's click this one, enter. We'll see if there is another collection output input devices. So there's an input device button, then under button is the value false. So again, I've already set up my LEDs, buttons, and buzzer. These are actually connected to the Raspberry Pi, Raspberry Pi. So it's pretty much straightforward. The LED is connected uh, to the GPIO 20, and the PWM LED is connected to GPIO 21, and buzzer for GPIO 17, and the button will be in GPIO 16. So don't you worry, this code will be on my GitHub, and I'll share it to you guys. So let's now let's move on. Now we just demonstrated the create operation. Now is let's do the read operation. So let me comment out this one first because we have already settled that one. So I'll name it okay, so that you will recognize this one, this collection. I mean this comment section. Create operation. So now for the read operation, the way we do this is we want our Raspberry Pi to continuously, let's say, read on this field right here, so that again it will output whatever the value is here. So basically, if this is false, the digital LED will turn off, and if this is true, this the digital LED will turn on. So we will edit the value right here in this Firestore console. So this would I mean the Raspberry Pi would read this value. So if we change this to true, it will automatically light the LED. So let's try to do that one. So in the read operation, um, again, let's reference the DB, then under collection, output device. Then under document, name digital LED. And we want, again, as you can might have already noticed, the attribute for for the create operation is dot set, and under read operation is dot get. So in so that's dot get. Yeah, so that's actually it. It will return a map of the of the data field. So this one, it is a the status data field and false value. So let's place it. Let's add it variable. So say read status. So read status, and again this will return a map or a dictionary in Python language. So you want to extract the map or the dictionary into separate fields, so that again we are only concerned of the status field. So let's do this by naming a dictionary variable first. So this one is doc. Let's name it doc dict. So the read status, read status dot uh, to dict to dictionary. Then let's name led status is equals to doc dict. Then enter the, now let's put the what uh, element field we are want to look on. Say status. So there. Then let's print this one so that we can see the result. If it does actually read the data. So print led status. So let's try this one. Hopefully there's no errors. Oops, there's an error. Non-type object is not subscriptable. So I think I've found out the reason why it gave this error. It's because I name it output devices, not output device. So again, be careful on that one. So stick this play. Let's run it. Hopefully we'll see the, yeah. So the value is printed. So we just read data from our Firestore database. So again, you want to make sure to make it into a dictionary first, so that you can read the a specific data field. So now that we have done this, we'll try to light our LED if this one is true, and if it's false, um, it will turn off. So okay, let's of course do it in a through a while loop. So our LED again, our LED will turn on if the status value here is true, and turn off if false. So let's just add a condition right here. I mean, we want to, sorry, I shouldn't have just, so again, while true, then we want to first again extract the a read, uh make a read request. So let's just copy this one. We are continuously reading the status field right here. So again, cloud Firestore is actually the the way it syncs is in a matter of milliseconds. That's why it is indeed a real-time syncing database. So and enter if LED status equals to because I mean, if LED status will return true, so returns true, LED on LED1 dot on. So else LED1 dot off. So again, we have read request here. Actually, this is a read request to our Firestore database, and we put it in our a while loop so that we can continuously monitor its value, and depending on the value right here on this status field, we will reflect it into our LED. So let me just turn. Let me just let you guys view my circuit here. So here I'm just using um, a mirroring application so that you can view on my circuit right here. So if again, let's run this one. Let's run our code. Oops, sorry. ED status. Oh, I'm actually missed a column right here. I'm actually still new in Python. I just learned it because I'm using a Raspberry Pi in our project. So make sure with that column right here and also this else column. So let let you guys see the circuit. So right here, if I enter play, so again, the green LED is actually the digital LED. So if I modify here right here in our Firestore database and update to true, you see it turns on. So if I enter it to false again, it turns off. So it's quite really fast, you know. It's amazing because it's a real time. So you can definitely use this in your applications. And so yeah, it's again just using cloud database. So that's it for the read operation. Let's stop this one. However, I discourage this approach um, using a read request. Uh, I mean add having a read request under a loop, because again it's a real time. This database is a real time syncing. So and I mean Raspberry Pi is also much faster in its while. Continuously looping this block of code. So essentially, you are making a lot of read requests to your Firestore, and that is a problem because if you are using a free plan here in our Cloud Firestore, because you're there's a limit on a read request per day in our Cloud Firestore. That might not be a case to you, but it's a really a big issue for me because I'm really working on a project that will it's like a system, and it is that will run in 24 hours. So if you put it the read request here, it will make a lot of requests. And if you go back to your Firestore panel and click to usage, it will see you the read request on your entire day. So this is pretty handy, so that you can monitor the read request, the write request, and delete request. So as you can see, the write and delete request has a limit of 20k per day. So again, it will reset the next day or tomorrow, and we just run our app. I mean our code, just a matter of doesn't yeah under 1 minute. And as you can see, it has already a 61 total of reads. So now imagine if running it under 24 hours, it will definitely uh, um, exceed the limit of 50k. So one way to do this is using Snapshot Listener. Basically a listener. It will update. It will only read whenever there's a change in your document. So I will make a video about it after this one because it's like an entire new topic for it. But in this case, let's use this read request, this traditional read request right here. I'll, I'll make a video on that one, don't you worry. So we're done with the read operation. So now let's work on with the update operation. So now we are just done with the read operation. So now let's head on to the update operation. So in the update operation, we'll be working on with the button. So as you can see right here under input device collection, we just again uh, set up, added this document button, and under the button document is the value data field, which is initially false. So the way it works, this one is that if it will continuously depending on the value of, the state of the button, it will reflect it right here. So it will update the value it right here. So if the button is clicked, it should update the value right here true. And if it is released or if it is not clicked at all, it will update the value here false. So pretty straightforward. So let's do it. So let's again enter let's put a while loop, and again we'll be reading the uh, state of the button. So if button dot is active, if means if it is clicked, uh, sorry, I'm really used to C. So make sure put the colon right there. If it is active, so you want the up to update the value right here to true. So same thing, you want to copy this document reference. So we are input devices collection. Make sure to change that one. Input devices. And if in the document, let's change it to button. And instead of get, again, get is for the read operation, to read or to get the data. This one right here, we just change it to update if you want to update something or a data field. So it's actually quite similar to the dot set, because you want to create an object, yeah, to just to update a field. So in this case we have an existing field called value. We want to update its value to true. So value to true if it is clicked. So that's it. And if it is unclicked, or if it is released, let's just copy this one. We want to update its value to false. That one. So I think we are good. Input devices, yeah. Then button. And if it's not click, false. If it's click, true. So just yeah. Let's just I'll let you guys show the my circuit for a while. So here. So as you can see, this is my circuit. So this one right here, this actually is my button. So let's first run the program. Let's run. So again, the initial value is false because we haven't clicked it yet. So if you click true, there it goes true. So if I release this button, it should not be active, so it should return false. There. So again, I always don't I always get amazed how real time it is. So uh, if I click it true, if I release it false, true, false, true. So there you go. Continuously updated this. So as you can see, uh, if you want to work on a project like something like a microcontroller or such, and incorporating this cloud Firestore database, you I discourage this approach again, including the like the write. This is like a write request uh, under the while loop, because again you're continuously writing it. Uh, in this case, you again, if it is not clicked, this case if it is not clicked, it would continuously write the value here false. So again, there's also a limit in the Firestore, the number of write requests. So again, this usage, we already reached 1.3k. So if you refresh this one, it should like uh, increase tremendously. So yeah, it will just really trust me, it will really increase because you included the write request in the uh, right I mean the in under a while loop, so it will obviously be called every time. So again, I'll explain this in another video using snapshot listeners, so that it will only read or write whenever there's changes in your um, database. So that's it for our update operation. So let's just close this one. And that's it for our update operation. And the next thing is the delete operation. So I don't usually use this because I don't, yeah, I rarely delete a document or a data, but uh, just to complete the crude operation format. If you want to delete, let's say you want to delete the uh, you want to delete the buzzer right here. So the way you do that is again call this uh, collection reference, yeah, collection reference, and under output devices, then dot document. So this, the name is buzzer. So if you want to delete um, let's say you want to delete a specific data field right here, the alarm, you want to remove that one, all you need to do is actually use the update attribute. So and again enter the specific data field that you want to delete, this case alarm, and you want to do this, call the Firestore uh, instance, then click the enter delete field. So this should delete if, after I run this one. So again, if you want to delete a specific field, and in case if you want to delete this document, you just put delete here. So and then, uh, this time I'll just demonstrate the how to delete a sorry how to delete a specific data field under a specific document. So play this one. So as you can see, it just removes itself. So buzzer has no longer has no data on it. So that's it for delete operation. I think I doubt that you would always use this. So that is for the delete operation. Now I want to expand more on controlling the GPIO. So we haven't touched the alarm yet. So same thing, same thing with the alarm. The way alarm works is just like blinking an LED, right? Uh, so let's say, oh yeah, we just deleted it. So let's enter it once again. Again, you can always modify right here directly in the console. You can always do that. So it was a Boolean data type, it's false. So and uh, So yeah, the alarm example. So this is actually just a read operation. So in the buzzer, so again it will, yeah, it's just the same with the read operation. Let's just copy this one. Just uncomment it. So let's name it buzzer dot get, and instead of status, it is alarm. And if it is false, the, yeah, there's no operation, I guess. And if it is true, if they, let's name this trigger alarm. Let's name it trigger alarm. If trigger alarm is true, if what is being read is true, uh it will basically alarm itself. So yeah, sorry, it was busy dot. Yeah, it's just same thing with a blink LED. In this case, we'll alarm it, and I'll just add some delay on it so that it won't will have that uh like not spontaneous alarm. So let's add this sleep here from time, import sleep. So it's like 1 second delay, then busy that off, then sleep again 1 second. So that's this one. Let's run it. So let's click run. So again, the alarm is false, and I think you can hear it on my mic because the alarm that I have right here is quite loud. So if I turn this to true, so I think you can hear the alarm, I guess. And if I click it to false, it should stop. Again, if I change the value to true, so you might have noticed the change of the pitch right there. I still need to fix it. So click false to turn it off. So that's it for the, if you want to alarm something that is being fetched on on the cloud, like this one, the Firestore is a good example. And lastly, I want to demonstrate, let's say, uh, I want to demonstrate something like the Cloud Firestore is the bridge. So uh, if I click the button, it should light an LED, but the value of the LED will be read from the database. So let me just do that. LED button. So it's like the Firestore or database. Firestore is the media or the medium. So what I mean by that is, again, while true, and from the read operation, we just, yeah, if, yeah, this one update actually. So if the button is active or it is clicked, it will, of course, um, it will update the value of the input device button right here. So it will come to turn it to true. And at the same time, we want our LED to continuously read this value, and if it is true, it will light up. So in that case, if so basically what we are doing is just combining the update and the read operation. So if, let's say, again, we are reading here, just copy code. Sorry. So again, we want to monitor the input devices. Input devices and the button. We want to continuously monitor the state of the button. Then .get again. Let's try this button state status. So instead of status, it's value. So we want to read again. We want to monitor the status of the button using through the database, and it will depending on the value of the button state, the LED will turn on if the value is true and turn off if the value is false. So if button state status is true, you want to turn on LED. So LED 1 dot on, else LED 1 dot off. So I think that should work, hopefully. So let's run it. So let me show the my circuit. So I almost forgot actually the PWM LED. So after this one, we'll do that. So again, this is my circuit. So this should trigger the LED if I click this one indirectly. First, it should read the database. It will update the database. Then the LED will read the database, and depending on the value of the button, it will trigger if it is true, and uh, it will turn on if it is true and turn off if it is false. I mean, I forgot to run. Sorry. Let's run that one. My bad. Oh, there's a problem actually. I forgot. Again, I forgot the colon. It might take a while for me to really get used to this if else in Python. So sorry about that. So again, so yeah, that one. So again, let's I run the code. So if I click this one, so the LED will light up, and if I release it, it turns off. So if I click the true, click the button, and if I release it, turns to false. So that's it for like combining the update and read operation. So now let's move on with the PWM LED or any IO devices that is like somewhat analog. Although PWM is not analog, it's just like altering the duty cycle. But anything that is not Boolean at all, not a 0 and 1. So throughout the entire video, we've only just been dealing with the Boolean data type because, of course, LED is a digital device, and although uh, well, LED in a manner of like 0 if turn off and 1 if turn on, And button, of course, is just a digital device. If clicked is one, and if released is false, or vice versa. So what if we have like the device, like again, LED is can be you can alter its brightness in terms of like the way we can modify it is using PWM. So it's not like Boolean data type anymore. So you want to pass on like a numerical value, or yeah, numerical value. So now what we are doing, what we'll be doing is changing the modifying the brightness of the LED in terms of the data that is being stored here. So under output device PWM LED, the brightness is currently at 0. So we can modify, we just modify right here the brightness. So PWM LED, let's name it that one. So again, basically what we're doing is here is the read operation. So because we are constantly reading the value of the brightness data field right here. So again, while true, colon, um, again, we'll be reading that one. So let's name this read brightness. Comment this one. So this one is under, yeah, output devices. Then this one is, the document name is PWM LED. So get its value, then turn it into a dictionary format. Then we want to extract the value of brightness. So brightness. So again, you gotta make sure that the LED that you want to um, apply PWM, you must of course initialize it in a PWM LED class. Make an instance of it and name it LED2. So it's pretty much straightforward. You just want to um, you just want to pass on 22 dot. So uh, enter LED2 and pass on the PWM value. So just click enter value, then equals the brightness. So I think that's it. Again, the range is 0 to 1. So okay, let's just add a trap right there, that if brightness is less, sorry, brightness is less than or equals to 1, is greater equals to 0. Yeah, you just wanna an and logic right there. You wanna make sure that the value is in the range of 0 to 1. So if it is, you just apply it there, and again, okay, let's try. If exceeds the range, let's just default, make the default value to 0. So I think that's it. Let's try to run this one. uh First show you the miser. So right here, so the PWM LED is this one, this color red. So this should be at 0 first if I run this one. Let me run this. Oh, again, I forgot the colon. quick run. So so I sorry for this. I forgot to change the variable. That's what you get when you always copy some code. So again, let's try to run this one. Hopefully no errors at all. So again, it's currently 0, so which is good because our initial value is 0. And what if we change the value here to, let's say, 0.5? It should have half brightness there. I think you can't. Oh, so yeah. Um, I think you can't clearly see if it's like the range of the value. Say 1. This should much be brighter than this one. Let's update. Yeah. So, and if I click like above exceeds the range, it should turn to 0. So there you go. Say 0.2. Date. Oops. Sorry. I'm actually using screen mirroring. This always gets like this. So again, it's 0.2, and if we further increment to 0.5, much brighter, and 0.7, I guess, should much be brighter, and 0.9 should be more brighter, and 1 brightest, not bright. Click 1, bright. So there you go. You can work on with like motors, number of steps on it. So using Cloud Firestore, you can really remotely control GPIO devices, IO devices using Cloud Firestore. And I guess that's it. I've tackled input and output devices using the CRUD operations of Cloud Firestore. And I hope you enjoyed the video. So thank you for watching.